Science time.
Yeah.
Science time.
Science
We're
time.
going to talk about, well, let's just call it fossils. There's more in here than just fossils. We're going to talk about fossils, which is, as I said, one of the coolest things. I think this is the sickest stuff. This is just the sickest. I love this. Fossils, of the types of science, I like all of them. That might not be true. I like most of them. This is one of my favorites. I love fossils. I just love fossils. Leo, I love fossils. They're cool. Fossils
Nice.
are cool. When you see a fossil, that's cool, right? Have you ever seen an actual fossil?
Yes.
We're going to
Yeah,
thank you,
thanks,
fossil.
Grandma.
After we do the, because you can't really see them very well the way my camera's set up, after we do this, if you remind me, and if there's time, we'll go into the lab and I'll show you some of the fossils that we have collected here in the library, which is pretty cool. What's a fossil? Define it for me real quick. Peyton, what do you think a fossil is?
Fossil. Oh no.
Anyone want to have a go?
A bone of some organism from the past that
So, it has to have been what? Does it have to be a bone?
Well,
No,
no,
because
it has
that's
to be
what we
the
think
body.
about, right?
Because I was about to say there is.
Examples or something like that of past existence.
Okay, yeah, so it's we could say, you're saying example, I think you might mean a different word.
Yeah.
It's something of a past organism, right? It doesn't have to be alive, it has to be from a living thing. It's what that it was once alive.
Proof.
Almost. We don't use that word in science, remember?
Evidence.
Evidence. So because we can say, at the most basic level, fossils are evidence of an ancient, let's not put ancient because it could be recent, right? Of a dead organism. Cyrus, please stop talking about that. Evidence of a dead organism. We think about it as bones. It doesn't have to be bones. We think about it as, sometimes we might think about it as a petrified wood, right? That's not bones, but we might think about petrified wood. It doesn't have to be petrified. We're going to talk about different kinds of fossils. But first I'm going to ask you, I love to ask this question. I ask this every time that we begin talking about fossils at any grade level. Pretend, you don't even probably have to pretend, you can probably find one. Imagine though, if you look outside, gaze outside with me, Colton would love this if he were here. Look outside, we're just going to look outside. Imagine now that we see a coyote running across the football field. Just imagine, okay? And then, as Cyrus says, very appropriate, thank you for adding that, Cyrus, he's going to pop him, he says. Cyrus shoots the coyote, it is dead. Okay, good, I'm glad you said that, Cyrus. Cyrus has killed the coyote. He brought his gun to school, he's also expelled, he'll never go to school again in his life. But the coyote is dead on the football field. Now imagine, no one touches the coyote. Not nothing, but no one. Also just decides to leave the coyote dead in the middle of the football field for a year. And when you come back, what will be left of the coyote?
Bones. And a stinkier remain.
Keep trying, because you're not right.
Bugs.
A carcass.
Well, that'd be under
You'll find a
kind of like
carcass.
I'm going to just wait till someone says their answer. What else? What would be left?
Nothing.
There you go. That's what I'm looking for. Okay. There would be, I'm positive, because of the way Mother Nature works, if you left just a dead coyote out there and no humans touched it, but we didn't say it was left completely, just that no humans touched it, there would be nothing left. You would see nothing of it in a year. Almost certainly. Why? Because, first of all, what's going to happen to all the juicy bits?
There's other animals that
Okay, yeah, so probably another coyote even, which is disgusting, but another coyote will come along and eat like the juicy bits out of that. Some little bugs will eat the little bits of juiciness, right? Does anything eat the hair? It doesn't really matter because once all the juicy stuff has gone away, the hair's just going to blow away in the wind, right? Well, all it's going to be left after a while is, as you said, bones will be left after a while. But even that, and I think this is kind of cool, this is not the only thing that happens to bones, but one thing that happens to bones is things like squirrels and deer, herbivores will eat the bones of an organism because they need their calcium too. Just like you need calcium. Where do you get your calcium from?
Jerry, the other
Milk.
coyote.
Milk, usually milk.
I drink the milk.
Yes, but in order for like a little herbivore, it's well documented that things like beavers even will eat the bones of dead organisms to get calcium. They like that, kind of like a salt lick. Anyway, when we come back in a year, nothing will be left. Almost always. Even just 1 year. Okay, so what's cool about this is that how does this ever happen then? Usually, let's put this, usually, decomposition. What's decomposition real quick? Let's pause. What's decomposition?
Breaking
down.
It's breaking down. It's breaking down, right? Usually decomposition leaves what behind?
Bones.
No, try again.
Nothing.
Nothing behind. After even, we won't specify a year, but after, God bless you, after only a short while. So what is special about, how come, God bless you, how come then there are fossils that are literally billions of years old? That's pretty rare actually. Literally millions of those. There are fossils that are 300 million years old quite frequently. We could go to, as we could go to the School of Mines and Rabbit Sea. There are fossils that are 300 million years old. How then, if the coyote will be killed and then nothing, just dust after a year, how could ever something be preserved for 300 million? That's a long dang time. What?
Wasn't it because like,
I was actually playing a Peyton, but that's okay. You go first.
wasn't it because like everything got destroyed?
Something
Like
don't look.
all the other things that would eat that got destroyed.
Okay,
as well.
possibly that might be the case. So you're thinking of at one very specific point in time. You probably are thinking of like when the dinosaurs all died off. You're saying that not just that one thing, but everything was killed, so there was nothing to come along here. That might have been the case once. That's not usually the case. So for a fossil that we found that wasn't the result of a mass extinction, we'll talk about mass extinctions in a while. Hayden, what were you going to say?
I was gonna say after that animal ate the bone, its feces would still be, it would poop it out, and then it would still kind of be there.
That stuff, yeah, okay, that's getting into something else, but that's what we call the law of conservation of mass, where the actual, like, atoms that make up that coyote still exist. That coyote's not gone. When I say nothing is left, nothing that's distinctly coyote is left. Like, the atoms that made up the coyote, probably even the molecules that made up the coyote, are still around. They're just in poop, like Peyton said. That's nice. But I'm talking about how come sometimes there can be a very old fossil. What's one thing, now let's do a different little scenario, unless someone has something else to add. Do you have any other guesses as to why maybe there could be? Go ahead.
Different types of fossil, like the way they decompose.
Yeah, so you're right. Like one thing we mentioned before that I turned the camera on is that there's such a thing as amber, and that's actually a fairly common fossil. And the little critters, there's a lady I go to church with that she has an amber brooch. It's really cool, and it has a little like I don't know what kind of insect, but there's part of an insect included in it, which is really neat. And that insect might be 100 million years old. It really might be.
Oh, that's what my grandma had.
And that's different from the coyote because what's special about that little insect as opposed to the coyote?
It might not, it may,
It got stuck in.
It's in amber, right? It's in something special that's preserving it. So there has to be special fossils have undergone a special preservation method. So basically, every kind of fossil we talk about, we're going to talk about how that was preserved. And I don't mean kind of fossil like species, I mean types of how fossils can form. Every one of them has its own special way. Two things we're going to talk about before that. If before the coyote's bones were gone, we went and we actually grabbed like, here's a rib bone. Does that count as a fossil?
No.
No, you're wrong, it does. It does. Even if the second that Cyrus plugs that coyote and it's dead, if we went out there and just gathered up its body and we're like, this is a fossil and we have this is a dead bleeding coyote right here, maybe even slightly still alive. It's just, we're like, it's technically right. We have a type of fossil we call original soft parts, which would include all of that. That's not really, like if you said to this is a fossil, someone they'd be like, do you know what a fossil is? It's technically correct, but people aren't going to agree that that's a fossil usually. Same thing with if we just went and grabbed a bone. That's a little bit closer, but those things we don't normally consider fossils. We do have types of fossils called original soft parts and original hard parts that are very rare that we get when something like amber has made it preserved. But usually there is usually almost always some preservation method. Yeah.
So what would you call it? Because there's like this one video I watched and it was like these people, they found a mammoth that was in ice that had everything on it
Yeah,
still.
that's an example of original hard parts and original soft parts, because it probably still has like its
So
organs.
it still
even.
has blood in
But there is, in this case, there's still a special preservation method, right? It was frozen, right? So there has to be some special preservation method. Now let's do our little thought experiment again, except this time, let's imagine that coyote ran across the field and Cyrus ends its life for it, and instead of just letting it sit there, we do one thing before. What's one thing we could do to not ensure, but to increase the odds that we would find something a year later?
I don't know, cover it in tree sap.
That's exactly the verb I wanted to hear.
Put it in
Cover
a
it.
spot.
We could bury it in the dirt, we could bury it in mud, we could bury it in snow, we could freeze it, but if we cover it, that's going to reduce the decomposition drastically. almost all fossils, the most common kind of fossils we find have undergone burial.
Uh-oh.
I can think of, I'm just kind of making this up, but this might be why so many cultures bury the dead humans that they had loved, right? I can think of two reasons. Maybe because they want to preserve it, and also because of what else?
It stalks when it's
Yeah, I was gonna say they don't want to sense the dead thing anymore, right? They don't want to look at.
They
don't
wanna
wanna
walk
look
into their house and be like,
They don't want to walk
Dead
outside,
bodies.
go
Like,
by the graveyard and
That's
stuff.
my
Oh,
that's my
there's
that's my
Jerry.
brother-in-law.
whoa,
And I'm
what?
like,
That's my
oh,
big grandma.
that smells
Smells
bad.
bad.
Right? I think probably human beings bury people that they had loved other human beings because
No.
they smell bad and they look gross. But also
No.
probably for preservation, right? Like, I mean, you can think of one. I know you can think of an example where people intentionally preserve the remains of a dead person. When did that happen?
So like Egypt.
What? Egyptian mummies is what I was
Egyptian
like. What did
mummies.
you say that, Jenna? Yeah, that's kind of the opposite of preservation because we're literally destroying that thing, but we're doing it so that we can always remember that, right? You said cremation, but mummies is what I was thinking. We're
But
intentionally
also,
preserving.
because they took out, so like they take out like the guts and all that stuff to
Yep.
preserve the body, and then they'd use like this type of, it was like lime,
Mhm.
and it's something else so it would like dry.
Not lime like the fruit lime. It was
Yeah.
calcium hydroxide, which is named lime. But anyway, yes, you're right. All that stuff helps preserve a body. So burial, and in fact, we could I'm going to put in parentheses as rapid burial. This makes a huge difference because if it's being buried over the course of months, much of it's going to be gone by the time it's fully buried. But if it's rapidly buried, sometimes that results in a fossil. Let's talk about the different kinds of fossils. So we already talked about two. I'm going to label this little list types of fossils. I'm probably just going to list them and then you can write down the definitions as well. It's also in your book or on your explorations on the computer. We had two that are not, I think, your book kind of breaks this up in a different way that I've seen before, probably to make it easier for you since you're 8th graders, but I'm going to show you the way that the types that I was taught. To me, this is truer. We have original soft parts. And when I say soft parts, that should be pretty self-explanatory, but give me some examples of soft parts we might find.
Like a dead
Yeah.
animal, a dead
Yeah,
animal.
so organisms, what else?
Ear.
Yeah, ear, things, cartilage, did I say organisms? I meant organs. Flesh, like muscle, and all kinds of soft parts. What are, if we put original hard parts,
That'd be like the bone.
Yeah.
bones and teeth, pretty much exclusively, maybe claws, maybe horns. Original soft parts and original hard parts, which of these do you think is more common to find for fossils?
Probably
Hard.
hard.
Hard parts, because they last longer, usually, because things don't as often or as much eat the hard parts. They do, but that happens more slowly. These two are both really rare, especially for ancient fossils. Especially for
Yeah.
ancient fossils.
So
Most of the time, when you see like, if you've been to any museum where you've seen like a dinosaur,
Yeah.
that is not the actual bones. We're gonna talk about what it is in a second. It's one of two things. It could be this that we call permineralization. I tried to do good penmanship because you might not have seen this word before, which we also sometimes call, and there's a little difference between these, but petrification. Have you heard of petrified wood?
Yes.
That has undergone this petrification. I'm going to talk about what this permineralization, or sometimes called petrification, means. What happens basically is the thing dies. And the thing is made of stuff. But it's not entirely made of stuff. You know, like, if we looked at it in a microscope at your bone, for instance, what would we see? Would it just be a solid disc?
No.
Has little holes in it, right? Little tiny pore spaces. So I'm looking at this is like a cross-section of bone, and these are pore spaces. What happens with permineralization, which is sometimes called petrification, is that the pore spaces, doesn't have to be in a bone, it's rarely in an organ or like an eyeball, but it could be like in a tree, right? The pore spaces that exist in the critter, any kind of critter, all organisms have pore spaces. Over time, the pore spaces get filled in with sediment or some kind of solution of maybe like limestone in water, whatever it is. Since the thing was buried in some mud or other solution of water and minerals, the minerals are all around it, and the minerals fill in the pore spaces, right?
Mm-hmm.
Yeah.
And it becomes rock.
Yeah.
And then over time, just like what happened to the coyote, the hard part, or the organism itself goes away. But what's left behind is this pretty good representation of what it used to look like, but now made entirely out of rock.
Yeah.
So when you see a dinosaur skeleton, it's shaped like a skeleton, but it's actually made of rock. Does that kind of make sense? So when you see petrified wood, no part of that is wood. It looks like wood. It's in the same shape as the wood. It might even be the same color or have the same pattern as wood, but it's actually made of rock. This is the most important, I would say, the most important kind of fossilization. This is the one that can create the longest lasting fossils. This is why burial is so important. If we bury our coyote instead, some of its bones or some of its tissues might become permineralized and get replaced with rock. The coyote itself is still going to vanish completely, but there's going to be rock left in the shape of the coyote. And do you remember, it doesn't have to be the actual dead organism. A fossil is evidence of a dead organism. So if we have a rock that is shaped exactly like the rib bone of a Tyrannosaurus rex, that counts as a fossil because it's evidence of the Tyrannosaurus rex. Does that make sense?
Yeah.
Well,
What?
because we named it, right?
Yeah.
It didn't call itself Tyrannosaurus rex.
Exactly.
We
But how do you know
just
it's
named
bone?
that pile of bone-looking stuff. We like, we're gonna call it Tyrannosaurus rex. Anyway, did anyone someone had a question? Peyton, you had a question about this.
Oh, well, yeah, my papa got like this big hunk of petrified wood. But wouldn't it like be, more, like, wouldn't you be able to find petrified wood more, like, than actual animals? Because, nothing likes to eat wood.
Yeah, there are things now that like eat
Yeah,
wood.
no.
Things do eat wood, but you're right, especially, and also because the trees themselves are probably more abundant, for instance, than an animal that's running around might have been. Yeah, petrified wood is, I would say, more common than petrified animal remains. Also, it's probably more frequent that the tree would get buried than an animal, because the things that, animals in nature don't bury each other on purpose, right? So it's a pretty rare circumstance that something is going to get buried. Like maybe a rock fall, or maybe it dies and then there's a snowstorm and then the snow gets a dust storm on top of it. It's pretty rare for something to get buried in nature. That's why fossils are somewhat rare. It's not like you're on your way to West and you trip over 9 fossils on the way there, right? It's not like Animal Crossing where you can just walk around your yard and dig up
Dig
fossils.
up a fossil
Yeah.
out of nowhere.
Did you have a question, Rhett? I thought you did. No. Okay, never mind. Let's move on.
If something dies, then something else is gonna wanna eat it.
Yeah, it's pretty usual when something dies it does not get buried, and then it gets instead
Yeah.
decomposed and destroyed. Another type of fossil, so does anyone have questions about permineralization, how that occurs? Do you see why this one would be really important? Because this rock, nothing lasts forever, Kansas tells us. You know the song Kansas is about dust in the wind? All we are is dust in the wind.
Yeah.
Anyway, nothing lasts forever, but this rock is going to last a lot longer than the bone originally would have, right? So that's why some of these fossils, to answer the first question I asked, how then, if the coyote's gone completely after a year, how can there be fossils that are 300 million years old? This is the answer. It turns to rock. It's not actually that thing anymore, it's rock in the shape of it. Okay, another type of fossil is carbon film.
What?
Carbon film. Your book calls this carbonization. I prefer for it to be called this. In a carbon film, do you know that almost all, on planet Earth, all life is carbon-based? We say that, things are made of carbon. Any living thing is made primarily of carbon. And when I say primarily, I don't mean that most of its atoms are carbon atoms. I mean that the atoms of it that contribute to its life, like DNA, its proteins, those are all carbon-based. Does that make sense? Are you aware of that?
Yes.
Yeah.
So when I say that carbon-based life forms, it means that the things that make it alive are carbon atoms, right? Carbon is a type of element. Carbon is number 6. See it? See it? Carbon. Anyway, so all living things on planet Earth are made at least partially of carbon. If something dies, we're talking a lot about death today. That's kind of the point of fossils. Something dies. Here's a dead fish. Nice. What am I representing with this squiggle line, do you reckon?
Water.
River,
Yeah, water. So the fish has died, it sank to the bottom. Just like a coyote, if nothing else happens, it's probably going to get eaten by other fish.
Yes.
I remember this from when I was a child. We had an aquarium, and one of the guppies died, and within half an hour, the other guppies had eaten it completely.
Yeah.
They're not picky. So anyway, unless something special happens, this fish is going to be gone just like our coyote in the example. But let's say in this case, it gets buried by another layer of sediment. Maybe the water was murky or something, and that caused the fish to die. When the fish died, it then got buried pretty much immediately, okay? Over time, more and more and more sediment builds up over top of it, squishing the fish. As it gets squished, the microorganisms that live in the fish's gut, right? All organisms, all macroorganisms, all big organisms have little microbes that live in us, decompose the fish, right? Making it into a slurry of just goop, generally fish-flavored goop.
Jelly.
Yeah, basically jelly. And that squishes out. But it squishes out still in the shape of the fish, right? So like this little, if we focus on this little part of the tail, that turns to ooze, but it stays where the tail was and it stays in the shape of the tail. And over time, as more and more sediment gets piled on top, the fish gets squished and squished and squished. Just like this, it's no longer a fish, it's just the carbon that was in the fish on the rock. So it's basically like a stain. Look at the picture of a carbonized fossil on page 7. Are you with me on exploration 1? I'm looking at the types of fossils, sorry.
So it's just basically squishing into like a flat rock.
Right. Yeah, it squishes it into the rock. It doesn't become a rock, like in permineralization. It just squishes the carbon that was in this organism out onto the rock, making basically a black stain in the shape of this. This happens mostly, I've seen it, with leaves and fish, is what I see carbon fills with, but it's not uncommon for other things too. So this, over time, this fish, instead of being a fish, the fish itself gets decomposed, but there's now a black carbon stain in the shape of the fish on the rock. Okay? Another kind is, let's talk about casts, and then we're going to talk about number 6 is molds.
What, mold?
Let's talk about them in the other direction, actually. I'm sorry. Where is Rag? Here he is.
What?
Molds and then casts.
Mold?
And then casts.
What, cast?
Casts.
Casts.
Okay. A mold occurs when, say we've got some soft, nice, squishy, soft sediment. Like, you guys know about kinetic sand? I'm sure.
Kinetic sand.
That's not really sediment, but imagine there's some sediment that has the same consistency or a similar consistency as kinetic sand, okay? And this can happen with lots of different stuff, but let's say that a little seashell dies, and it falls onto the soft sand. And it leaves a little hole in the shape of a seashell. Okay, so far so good. You can imagine that happening.
Yeah.
And then just like it always happens, something comes around and eats the seashell. So the seashell itself is gone, but what's left behind is what?
The imprint.
The imprint. A hole in the shape, I'm just going to label it hole. A hole that's the shape of the seashell. And then over time the rock, while it was soft and squishy, now hardens, and we're left with a mold. A mold is a hole that's the shape of the organism, right?
So that's how like sometimes you find a rock
Mold
that's
is the
empty,
what?
but like in the shape. Of
Yeah,
it.
a mold is a hole in the shape of an organism. Do you see why this one would last for a long time? This one's not going to decompose because it's actual literal rock. It's just a hole. A hole can't decompose.
A hole in what now? They can
A
get
hole
covered.
in the shape of the organism.
It can get covered.
It can be covered, and we're going to talk about that in 1 second. A cast forms, Cyrus, when that same hole, later, there's a hole in the hard rock, and it gets filled in with some other kind of sediment. And that's called a cast.
So it just gets filled in.
It gets filled in with something else, and then the something else, we could pluck that out. And how would this something else relate to the shape of the original object?
It's gonna pop out as like a mold.
Yeah, it'll be the same. The mold is a hole, so it's negative space. And then it's going to fill in with something else, this I've represented here with purple. And that can pop out, it'll be just the exact same shape that this original seashell was, right? And that's called a cast. This, when you go to the museum and you see the dinosaur skeleton, what has actually happened, they found somewhere a permineralized, as we talked about, dinosaur skeleton. Super cool. But also extremely rare, and they don't want to have a little 6-year-old running their hands over. So what they do, they take this permineralized skeleton, they put it in a closet somewhere, and they intentionally make a mold out of clay, like man-made clay, or else maybe plaster, and they put that bone into it, and then they fill up that mold that they have made with plaster. And so what you actually see at the museum most often is a man-made cast of a man-made mold of a permineralized dinosaur bone. So a lot of stuff has gone into making this object,
So,
but it's still roughly the shape of the dinosaur bone. Yes.
That would take a long time.
It
So
does.
they're
yeah.
just doing that, but faster way.
Yeah, and sometimes they make it out of something you can do is make it out of bronze, which is cool. Make like an actual. You know that ram, the bronze ram in the front.
Yeah.
It's the same kind of thing. Made that. What they did was someone made out of probably clay, like just modeling clay. They made the shape of that ram, and then they pressed that into some wet sand. Because they can't like just coat the modeling clay in molten bronze because it would melt. And so they pressed the clay that they had made into wet sand, and then they fill that wet sand with bronze, with molten bronze, and then it's in the shape of the original modeling clay was.
Yeah.
Yes.
Have you seen the 3D billboard? Those things are so cool.
I have not. I don't know why we're talking about that.
I don't
Let's
know.
talk about. We're gonna have one more. We have room for one more here. This thing, I don't know. I'm gonna put it over to the side. One because I don't have room, and another because it could really fall into these other categories. But a trace fossil, it really should not be on this list at all. Probably a trace fossil is when any of this happens. Are you guys paying attention?
Yeah.
When any of this happens with the behavior of an organ. So a trace fossil is behavior, indicates behavior, whereas a body fossil indicates what?
Body.
Yeah, how it looked, right? It's structure. Which one of these do you think is more valuable? Just trace fossil and body fossil.
Probably is body fossil.
So body fossil tells us how it looks, but a trace fossil is cool because it tells us how it be. Because obviously we cannot observe the behavior of a dinosaur anymore. They're gone, right? So the only way we know about their behavior is through these trace fossils. Trace fossils can be things like, I'm writing these down, footprints, right? That tells us how it did what. What kind of behavior does a footprint tell us?
It can
tells us
walk.
how big
How it moved, right? Yeah, so that's how we know. That's the evidence we have that Tyrannosaurus Rex walked on its two back legs, right, as opposed to its front paws too.
T-Rex is not good. We have some front T-Rex paws.
That's how we know it because we have trace fossils. How do you reckon, what trace fossil do you think provides evidence that the Tyrannosaurus Rex
Doesn't live.
laid eggs?
Probably egg.
Eggs, just
Eggs.
eggs. A nest is a trace fossil. What evidence do you think, I think this is the coolest kind of trace fossil. What evidence do you think we have that Tyrannosaurus Rex was carnivorous?
Probably its teeth.
Yeah.
Okay, that counts as a body fossil. But what other evidence do you think there is?
Its
like
stomach,
mouth.
mouth, feces.
The tongue.
Say it again, Rex.
Feces.
Poop. The poop. We have this word. The one type of trace fossil is a coprolite, which is gross, but it's fossilized poop of some kind, and that's actually it's gross, but it's extremely important because that tells us what it ate, right? Or it can tell us what it ate.
How do we know it came from the...
Okay, yeah, good question, because usually we'll find generally I don't know of it ever happening with an actual Tyrannosaurus Rex, but we'll find some eggs that have been identified to be Tyrannosaurus Rex, and then near them will be some little poopies, and we can assume, right, that the evidence kind of piles together that they must be Tyrannosaurus Rex poopies. And then we'll find bones of something in there, and that bone means that it was, obviously, it didn't just accidentally swallow bone, it ate something that had bones. Your book also talks about tar pits, amber, and frozen parts, but those are all, amber counts as original hard parts, original stuff, right? It's that actual, when I see that lady at Church's brooch, there's an actual insect in there, right? It's not permineralized, it's not carbon film, it's not a mold, it's not a cast, it's an actual insect inside that amber. In Jurassic Park, the guy has an amber thing on his cane that is an actual mosquito that they were in Jurassic Park able to draw blood out of and make the dinosaurs. That can't happen because DNA has a half-life, but it's kind of an interesting idea, right? And it's true though that is an actual organism inside that amber, which is really, I think, really neat. One way, this is the absolute coolest thing. We have evidence. What one of these do you think can provide evidence? We now know that almost all dinosaurs, especially in the Cretaceous, which is the last period of dinosaurs, had feathers. What evidence do you think of these could provide evidence that dinosaurs had feathers? Mold, yeah. So a lot of times we'll find a dinosaur, he'll be the fossil, there'll be dinosaur bones and crap, bones, head, right? Here's all its bones, and then there'll be a mold around it in the shape of feathers, right? So even though its feathers are completely gone, there'll be a hole in the shape of feathers. Another one, and I'm only aware of this ever being experienced once, but there's a huge It was discovered in China, I think 2 years ago, a huge chunk of amber, like that lady has with the insect in it, but it has an actual dinosaur in it, with actual dinosaur feathers inside the amber. Like real,
I would keep those feathers.
it is so cool. I think that is the coolest thing.
That is really cool.
And that's really valuable because it tells us not only dinosaurs had feathers, which we already kind of knew, but it tells us the exact like color
Yeah.
and makeup of those feathers, and we know they're very similar to bird feathers, and we're going to talk about why that is here in the near future. But I think that pretty much
Covers it?
covers, you know what, that actually only about covered exploration 1. We'll talk about exploration 2 and 3 tomorrow. I got kind of carried away. I just love fossils so much. Do you have questions about fossils?
Yeah.
Do you find this was helpful at all, or
Yes,
did you already know all this from your
Honestly, I love this lesson.
reading? I do too. Do you have questions, Angie?
I don't know.
What's your question, Angie?
I don't have a question.
Make one up.
Are you stupid?
Hey!
It's a random, but any
I wanted Angie to have a good question, Cyrus, and then you've wrecked it for everyone.
Yeah.
Okay, if you have questions about fossils, we'll talk about them, but you can do exploration. I think, I would still like you to have exploration 1, 2, and 3 done, and we'll talk about exploration 2 and 3 tomorrow while we go over them. Okay?
Yeah, we changed